Hello student, today I am going to explain how to derive the formula for finding the length of the plane curve. So first of all, you need to note down that to derive the length of a plane curve, a certain value of x, say x is equal to a to x is equal to b, for the first case, that is for a function y is equal to fx. What we have to note down is that fx should be a continuous function and the derivative of fx also exists in that interval. So in case 1, you take let y is equal to f of x. Now this fx, the condition that this fx should satisfy are, the first one will be fx is continuous in say in the closed interval a to b. Number 2, f prime of x exists in the open interval a to b. So now in order to find the length of the given curve from A to B, then we need to, let us draw the graph of the curve of this y is equal to fx. So draw this one xy axis, this is the y axis, x axis, this is the y axis. Now suppose the curve is like this. And then if I take this point, let us take this as x is equal to a, then I need to find the length of this curve from x is equal to a to x is equal to b. That means from here up to here. So how to measure the length of this plane curve now? By using these steps here. So first of all, let us take, we can divide this curve into many points and then join those points with the straight line. You join the successive points. Then in this case, suppose this is a point and this is a point here. So that means you draw this straight line, you join this point. Now when you draw this line, then you drop is perpendicular to this one. And then this, you join this point from here to here and from here to here, where this line here represent the base of this triangle, or is a line which is parallel to the x-axis, and this line is parallel to the y-axis. That means you can find what will be the length from here to here on the x-axis and from here to here on the y-axis. Suppose the length from here to here on the y-axis is dy, and then this is dx. That means from here to here the length is dx. Now if the points are very close, for example like this one and this, then you'll see that exactly the length of this the straight line joining these 2 points will be exactly equal to the length of will be equal to the length of the curve. So in this way we'll find out what will be the formula for that one by using this condition. Here I'm taking this 2 point, and then you see that it may be slightly different between this red line here and the curve represented by this one. So what we need to do now, here I'm just showing this one so that you'll be more clear with this derivation. Otherwise, in general, you have to take those 2 points very close to one another so that length of those straight line will be exactly equal or approximately very near to this one, to the curve, length of the curve. So now here you take this particular case. Let me take this one as A, this as B, this as C. Now what we notice from this graph is that ABC is a right angle. Triangle ABC is a right angle triangle. Now if I take this one BA as DL, D small l, that means the length from A to B. Now by using the Pythagoras theorem in this right angle triangle BAC, what is the hypotenuse here is DL. So what will be DL, the whole square? This will be equal to the sum of the square of the other side, that is the base and the opposite side. So it will become dx the whole square plus dy the whole square. Or DL is equal to square root of dx square plus dy square. So now you see that this dx and dy, that means this one, that means the length from here to here is dx, and then the length from here to here is dy, which is on the y-axis. If you produce this one to meet the y-axis, and from this point also, that will be the length of dy on the y-axis. So now here you make take many points in this case, and since fx is continuous in closed interval ab, f prime x is in open interval ab, and since this is the curve, since we are to find the length from x is equal to a to x is equal to b, then what will be the total length? So continue in this way, then what will be the total length or the required length? Required length will be denoted by L. This will be equal to, since in the definite integral the summation sign is same as the integral sign, you have done it in class 12. So here the required length will be integral. Instead of taking summation of the length from here to here plus the length from here to here, the length from here to here, then we can take it as the length from x is equal to a to x is equal to b using the integral sign. So x is equal to a to x is equal to b dl. So what is dl here? It is this one integral a to b square root of dx the whole square plus dy the whole square. Now, since I've taken y to be a function of x, that means y has been expressed in terms of x, then in that case, if you take the derivative of, since I already mentioned here that the derivative of this x is, so you can differentiate this one. So dy dx in this case will be equal to f prime of x. So that means this one x is. So here what you need to do now, take out this one dx, square root of dx as a common factor, dx whole square, then into 1 plus dy dx the whole square. Okay. So take out dx the whole square so that you'll get this operator dy dx. Now dy dx represent the derivative of this function which x is. Okay, so that's why we can express this one as dy dx. Had the derivative does not exist, then in that case we cannot express this one. So always remember that the function fx should be continuous and the derivative also exists in the open interval ab. Now next, this will be equal to integral a to b. Now square root of dx the whole square. So it will be dx. Then into square root of 1 plus dy dx the whole square. So this is integral a to b square root of 1 plus dy dx the whole square dx. So how we are getting the area of this, not the area, the length of this plane curve? By using this Pythagoras theorem, you can see that by joining any points on the curve, you'll get a straight line, and that one will be approximately equal to the hypotenuse. And then you can use the Pythagoras theorem that the hypotenuse is equal to the square of the hypotenuse is equal to the sum of the square of the other two sides. Then you'll be able to get the length, required length. Now, in case the function the function x is expressed in term of y. For example, x is equal to say 4y square or 4y square plus y and so on. Then in this case, you see that x has been expressed in terms of y. So what will be the formula for this one? Since here also g of y should be a continuous function in that particular interval, say c to d, then the derivative of this g prime of y also exists in the open interval c to d. Then in this case, for case 2, that is if x is a function of y, then it means that g of y is continuous in, say, in the closed interval c to d, that is from y is equal to c to y is equal to d. G prime of y exists in the open interval c to d. Then in this case, what will be the required length? L is equal to integral, now y is equal to c to y is equal to d, square root of that one dx the whole square plus dy the whole square. Again, now in this case, for x is equal to g of y, you have to take out dy as a common factor. So it will be c to d square root of dy the whole square into dx dy the whole square plus 1, which is equal to integral c to d square root of dx dy the whole square plus 1 dy, because square root of dy the whole square will be dy. So we are getting for this one, for the case of x, function x which has been expressed in terms of y, the formula will be integral c to d square root of 1 plus dx dy the whole square dy. Why we need to get dx dy here? Because from this function x is equal to g of y, you need to differentiate x with respect to y, that is dx dy will be equal to g prime of y. So hope it is clear now how to derive the formula for the length of the plane curve.